Alright guys, here is a new unit, so hope you all have a new start. This unit is on trigonometry, trig. I'm sure a lot of you know what I'm talking about, SOHCAHTOA, and of course, we go beyond this. And for those of you who are planning on taking Math 30-1 in the future, make sure you know this, because we have one big unit focusing on trig in 30-1. Alright, so for today, we are starting on 2.1 angles in standard position. So we'll talk about some basic stuff that you may still remember from last year. And even if not, you all should have learned this last year. Never mind, I'll quickly brush up your memory for the rest of today's lesson. And of course, we'll learn new stuff on top of the Math 10C review. So, first thing, let's talk about this. What makes an angle? Okay, so what makes an angle? An angle is formed by two rays with a common endpoint. So it looks like this. You have two lines, and they join at one point. And the ray that is the starting point is called the initial arm. So this is the initial arm. This is your starting spot. Starting point. Okay, the ray that is the end position is called the terminal arm. So it starts here and ends here. So you can think of it this way. It starts here, go all the way, and of course, it goes beyond. And the angle in between these two lines, or these two rays, by convention in math, we call that angle theta. Okay, so next, an angle is considered to be in standard position. So, what do I mean by standard position? If we consider the initial arm to be the positive x-axis and the terminal arm is a ray rotating from about the origin, like this. So this is my starting point, my initial arm. It can end here, 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 here. Alright, so this is basically our starting point. By convention in math, when we say standard position, anyone who knows math, including yourself now, would know that it starts at 0 degrees and then go counterclockwise. Like that. So if we rotate counterclockwise, then the angle is positive. So anything starting from 3 o'clock, go counterclockwise like this. We can represent that with a positive sign. Okay. And if we rotate that clockwise, like this, starting at 3 o'clock again at 0 degrees, go counterclockwise, like that, then we use the sign negative to indicate the angle. Like this. That's negative. This is positive. So Math 10C stuff, let's measure this one here, starting from this point. So if you look at this, it goes from here, going that, it stops here. So how can we describe this angle? We would just say, oops. So we would say that it is angle theta equals, in this case, starting from here 0, 10, 20, 30, 40, so on and so forth. It is, I would say, 140 degrees If you get a slightly different angle, it's fine. And make sure you also put the degree sign there. Okay, so now let's measure the angle. This one here. Oh, sorry, I've got to indicate that this is theta 1. So theta 1, or theta is fine. But okay, anyway, so this one, as you can see, the direction of the arrow starting from here and then move all the way here. How wide is this angle? Just let you guys know that for this course here, we are not going to use a protractor, okay? Because we are doing things that is more technical. So line them up. So going from here, that's the starting point, going clockwise. So if you look at this, this is, I would say, 75 degrees, 74 degrees, doesn't matter. So theta 2 is, in this case, 80 degrees. Sorry, this is 75 degrees, 75 degrees. But then because you measure the angle counterclockwise like this, so you put a negative in front. So for anyone who knows math, when they read this, a positive angle, they know that it was measured counterclockwise. And when they see a negative angle, they know that it was measured clockwise. Okay, so let's keep going. Next. You might want to pause for a few seconds and think about what's going on here. Angles in standard position will always be shown on a Cartesian plane and will be found in one of the 4 quadrants. So for any plane, it is divided into 4 different quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. So from Math 10C, I hope you know that it starts from top right hand corner. You can think of this as how the city of Calgary is being divided. Northwest, northeast, southwest, southeast, except in math, we start off here and call that quadrant 1, first quadrant, then move here, quadrant 2, then down here, quadrant 3, and then down here, quadrant 4. If you look at this, each quadrant would have specific value and sign for the x and y coordinate. So here for quadrant 1, x would be positive, y would be positive. X positive, y positive. Quadrant 2, x would be negative, y would be positive. And then for quadrant 3, x would be negative, y would be negative. So both x and y are negative. And then for quadrant 4 here, starting from the origin here, 0, 0. So quadrant 4 would be positive for x and negative for y. Alright? Next, let's look at the angle bounded by each quadrant. So if you look at quadrant 1, so you might want to look at this. This is 0 degrees, 0 degrees, 90 degrees. This is 180 degrees, and this is 270 degrees. And then go back up here. Now you don't call that 0 degrees, you call that 360 degrees. And then you can keep going. Another 90 degrees. So that gives you 450 degrees, and another 90 degrees, so on and so forth, right? So for quadrant 1, it is the angle theta is somewhere between 0 degrees and 90 degrees. So don't just say it this way, okay? Let's be a bit more specific. Between 0 and 90 degrees, it is actually less than 90 degrees, but greater than 0 degrees. And from junior high math, you probably learned that any angle that is between 0 and 90 degrees, you call that acute. Notice that we do not include the angle here, 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 and here. So all these angles right on the x positive, negative x-axis, positive, negative y-axis, we call that quadrantal angles. So quadrantal angles. So these are the angles right on the x and y axis. So that means 0 degrees, 0 degrees, 90 degrees, 180 degrees, 270, 360, so on and so forth. Alright, now let's look at the second quadrant. So the angle theta would be somewhere between 90 and 180 degrees. So again, let's be a bit more specific. So angle theta is greater than 90 degrees but less than 180 degrees. And again, from junior high, if this is the case, we call those angles obtuse angle. Sorry, obtuse. Alright, so quadrant 3, somewhere between 180 and 270. So angle theta is less than 270 degrees but greater than 180 degrees. Alright, next, quadrant 4 would be somewhere between 270 and 360 degrees. So angle theta is less than 360 degrees but greater than 270 degrees. And again, from junior high, you should have learned the term. So for any angles that is greater than 180 degrees, we call them the reflex angle. Fine. Okay. Reflex. Okay, so new stuff. A new term here, reference angle. So for every angle in standard position, starting at 3 o'clock or 0 degrees, in standard position, there is a corresponding acute angle called reference angle. What am I talking about? The reference angle is between the terminal arm and any part of the x-axis. Actually, it is the closest x-axis. You'll see in a second what I mean. So draw an angle in standard position in each quadrant and identify the reference angle. So let's do these two here. So let's focus on quadrant 1 for this specific example. Let's say we have a terminal arm here. And of course, you call this angle theta. So how do you draw the reference angle? This is how you do the reference angle. The reference angle is between the terminal arm and any part of the x-axis, as I just mentioned. That's not the best way to look at that. To any nearby x-axis. So if you look at this, you have an x-axis here, but of course, this x-axis would be closest to the terminal arm. So that means you start from here and then measure whatever you have. Sorry, of course, we need to put an arrow here to indicate that if you want. So in this case, this is my reference angle, theta r. I know you say, Cheng, they are the same, aren't they the same thing? Yes, in this case, if you have an angle in quadrant 1, the reference angle would be the same as the normal angle. So in this case, your angle theta is the same as your reference angle. Now let's look at quadrant 2. Alright, so in this case, we just have an angle here. How do you measure the angle theta here? going from 0 degrees, 3 o'clock, like this. This is your angle theta, math 10C stuff. Now, how do you find your reference angle? Okay, so in this case, you look at the terminal arm, initial arm, terminal arm, match the terminal arm to the nearest x-axis. So this one, if you cannot see what's going on, then perhaps you can do this. So connect a point on the terminal arm with the x-axis. And in this case, you can see that there's a triangle, and whatever angle inside that triangle, that is your reference angle. So now, how do you find this reference angle? Just this one. This is 180. If you take 180, subtract it by the theta. So take theta from 180, then that will give you a reference angle. So your reference angle is this whole thing, 180 degrees. So 180, subtract theta from this, because this plus that gives you 180. So if you take away angle theta from 180, that will the remaining would be angle theta. So 180 minus angle theta, whatever angle theta is. Okay, so let's move on to the other two cases. So what is the reference angle in quadrant 3? So quadrant 3, like this. And your original angle theta will be starting here all the way and then stop here. So this is your angle theta. So how do you find your reference angle? Same thing. If you cannot visualize this, this is a terminal arm. So connect a point on the terminal arm to the nearest x-axis. So this one, not that one, so this one here. So that, and then the angle inside, just this, right here, is your reference angle. Now, a few seconds. How do you write an expression for your reference angle? Have a look at the previous two examples we did. Have a look. Now, how do you write this? So if you look at this, you'll probably think, oh, how am I supposed to do that? So if you look at this is angle theta, and this is 180. So what you can do is, there are two ways you can write that, but I don't bother to show you both ways, so I'll show you this way. So we know this is 180. So 180 degrees plus the reference angle gives you the angle of the whole thing. Okay, 180 plus this gives you the whole thing, which is angle theta. So now you can rewrite this. So what is the formula for finding the reference angle? Subtract 180 on both sides. So that means the reference angle is theta minus 180. Alright, so last scenario, quadrant 4. So that means we have an angle here. So what is my angle? Theta, starting from here all the way counterclockwise until you get to the terminal arm. So this gives you angle theta. And then what is my reference angle? You can use the same trick. So this is my reference angle, theta r. Again, there are two ways you can write this. I'll just show you one way. If you can figure out the other way, good for you. So if you look at this, we know if we take angle theta and add that to the reference angle, the sum would be 360. So angle theta plus the reference angle gives you 360 degrees. So if you subtract angle theta on both sides, then that means your reference angle is 360 degrees minus theta.